Hi everyone, it's nice to see you again. Today we're going to discuss the strategy of how to find the domain and range for some kind of functions. Finding the domain. To find the domain, we have a general strategy that we can use to every kind or every type of functions. So we're going to have first case 1. If we have the function as a polynomial function. If our function of x equals to Pn for x, which I mean by Pn, it's a polynomial as const a0, which is constant, a1, a coefficients. These just arbitrary coefficients, x plus to the an xn. This is called a polynomial of the degree n. For example, any coefficients here, and we can just move on adding some terms, coefficients multiplied by x equal with some exponent. For example, 2 will be, the polynomial would be of degree 2, 3 the polynomial would be of the degree 3, and so on. So to find the domain of the polynomial, the domain of this function, of this case, if the function was a polynomial, the domain of this function will be always R, because we have no problem of feeding any real number to the polynomial. The result will be always well defined. This is too easy, the easiest, almost a trivial case. Case 2. Case 2, square root function. If we have a square root function, for example, of x equals to a square root for a certain expression, any expression. So to find the domain of this function, to find the set of numbers that I can substitute or feed the function with, and the result will be well defined, I need to make restrictions that the expression inside the square root must be 0, or have to be 0. So I will tell him that the domain of the function f in case 2 will be all the real numbers x equal to x belong, all the real numbers x belongs to R, such that g of x, or the expression inside the square root, greater than or equal 0. Okay, and we're going to solve the questions, the exercise in the book, and we're going to see how to apply these notations to solve the equations. So this is the case 2. I'm going to take all the cases and find the domain, and then going to explain how to find the range for these functions, or for these cases, because almost we have just one way to find the range to all cases. Case 3. Case 3, make it square. The rational function. Let me now divide case 3 into part A and part 2. Part A is just a function of x. Let me change the color. A function of x is just a rational function. I mean by a rational function, the fraction, the function that can consist of a fraction, which means numerator and denominator. So I will assume that h of x in the top and g of x in the bottom. In part A, where h of x and g of x are polynomial. In this part, I will divide case 3 into two parts. Part 1, when I have the numerator and the denominator just a simple polynomials. So the domain will be the domain of this function, of this case A, of this case 3 part A will be all the real numbers. X belongs to R, to the real line, such that gx never 0, because I cannot divide that by 0. Okay, this is a straightforward case. Part B, which is the most interesting part, of x equal to, okay, and where h of x or g of x or both are square in this case, in case part B, it is just a rational function with the numerator and denominator, but it could be the top term could be a square root, and could be the expression in the bottom could be a square root, or could be both of them a square root. So what I'm going to do, how can I find the domain of this function? I'm looking for the domain to this function, to the main function or the big function of x. So I will say A, find domain of the function h. B, find domain of the function g. And then C, I would say the domain of the function f equal to the domain of h intersected with the domain in G minus all the elements in R such that g of x equal 0. So what I'm going to do now, what we already did in the notations now, we found the domain of the numerator and we found the domain of the denominator, and then so as I said, where hx or g of x or both, I'm talking about the case when they are both a square root functions. But if I have a polynomial on the top or a polynomial in the bottom, so I would have I wouldn't have any problem. So I will not have any problem. Why? Because if the denominator is a polynomial, the domain, its domain will be R, and if this one is just a polynomial and this is square root, so I'm going to do the same strategy. I'm going to find the domain of the top and the domain of the bottom, and then I'm going to do intersection to them, because I need the domain of this function to be the common elements that doesn't make any problem to make these functions well defined. And then when I finish, I will extract every element that makes the denominator 0. Okay, so I can say that these notations almost find the domain for every function you could encounter in your study in this section. Okay, in your study in algebraic functions, because we have algebraic functions, logarithmic functions, and hyperbolic. We're now talking about these kind of functions: polynomial, square root functions, rational functions from part A, from kind A and kind B, or two types, and these denotations to solve every kind of these questions. Finding the range. because I will make this lecture just to these notations, and the next lecture I'm going to start to solve the solutions. To solve the exercises of the section 1.1, which is about 6 functions. He gave us, I think, in the exercise there are 6 functions, and he wants us to find the domain of range, the domain and the range of these functions, and then he has about 4 functions. He gave us it's a graph, and he wants us to determine if these graphs belongs to a function or a ratio or a relation. So finding the range. Roughly speaking, we have just one strategy to find the range for every kind of these functions. Okay? One, after I finish writing these notations, finding the range of the function. First, we need to change the formation or representation from y equal to f of x, mean y written in terms of x, to x written in terms of y's. This is the first step. The second step, find the domain of the new function. I will get a new function. I will find the new function of, I will find the domain of this new function. The domain that I found, which is belong to the new function, will be the range to the original function. But I have notation here. I want you to pay extraordinary attention to it. Be aware or careful. Pay attention to the variable, to the restriction. Pay attention to the restriction of x. I want you to pay attention to the restriction of the variable x, or the domain of x. I will tell you what I mean by this notation when I start solve the exercises in the next lecture. I hope the lecture was easy and straightforward, and please don't forget to hit like and subscribe and leave a comment. Please tell me what's your impression. This is my third lecture in English. I've been doing lectures in mathematics like calculus for undergraduate students since about 2014, and this is my third lecture in English. I did some lectures like in private, but this is on YouTube. This is my first lecture. Please leave a comment, any comment. If it's positive, if it's negative, just tell me, correct me, and I will be thankful for you. Thank you guys, and see you again.